The explosive growth in voice and data communications has come to symbolize the modern age. Communication has played a key role in bringing the world together and driving economic growth. Yet using satellites to communicate from the remotest corners of the globe remains expensive, and the bulky antenna restricts their use on the move. Until now.
What we've come up with really is the holy grail of antennas that people in the industry have been seeking for 30, 40 years.
And this is it, an A4-sized antenna, the width of a paperback.
In a nutshell, it's a completely reimagined antenna, and it will have a watershed effect on communications and radar technology.
It's a revolution that started with these men here at the Royal Institution in London. This is where Michael Faraday discovered electromagnetism, the basis for electronic communications. And this is where Phasor, their company that invented the new antenna, is based, in an office above Faraday's own laboratory.
Phasor has the opportunity of transforming the market and have an impact on all our lives.
The key element of this new development is the fact that there are no moving parts, and it is auto acquisition. So you will lay it down on the ground. It's a slate you put down anywhere. It will find the satellite all on its own without any installation or pointing issues. And if you're on a moving platform, it will track that movement as well.
You just point it at the sky and it does the rest by itself, electronically.
We're replacing, with this low-profile system, not only the mechanical parabolic reflector that you would generally associate with a dish, but also the amplifier that goes with it and the low noise amplifier with it. So it's virtually the whole communication system down to the baseband signal that the user could take. It is the whole integrated unit in a very thin profile unit.
And you can put it anywhere. On planes, trains, ships and automobiles. It's more powerful and more flexible.
Our antenna is something that is so thin that it can be applied to the outside of a fuselage of an aircraft or the roof of a train. It allows you to support some really high data rate communications so that everybody will have the Wi-Fi with the inexorably increasing demand for data rates, that every user is needing more every day, and there are more users every day. So the growth in demand is phenomenal.
At the heart of it is this tiny square chip. It's basically a satellite box. Put a load of them together and you have this.
The panel of which the antenna is composed consists of a large number of copper, gold-plated resonant patch antennas, and behind each of these antenna elements there is an array of integrated circuits. Each integrated circuit is connected through the thickness of the board to the patch antenna this side. Now this means that the radio frequency loss between the antenna and the integrated circuit is minimized, and that all the communication between the elements is done at a very much lower frequency. And this is a big departure in terms of phased array antenna technology. This enables an antenna to be built with as many elements as are necessary to achieve the required level of performance.
The panels can be added together to achieve the capacity required, and they're more powerful than the parabolic antenna, and they have higher data rates. The implications for mobile connectivity are immense.
There is a number of multi-billion-dollar opportunities that Phasor is targeting in two main groups: the satellite communication on the Move group, so providing connectivity to moving platforms, and in the phased array radar markets, which is providing imaging and radar capability to a number of applications. For example, in satellite communication to passenger aircraft, there is tens of thousands of aircraft which could adopt a solution at about $100,000 per antenna, creating a multi-billion-dollar revenue opportunity there. Similar for business jets, similar for trains, for ships, and other applications. In the radar applications, we're talking about weather monitoring, air traffic control, wildfire, smart city programs.
And Phasor has already identified partners in each market segment.
So in each of these target markets, Phasor is working with identified major players. These cannot be disclosed due to commercial sensitivities, but can be disclosed under NDA. In radar, we are in touch with the largest US prime, in prime contractor. In satellite communication for trains, we have a partner. For satellite communication for aeroplanes, for business jets, for unmanned vehicles, for land vehicles. They're all multi-billion-dollar programs already available, which we're tapping into.
And Phasor is identifying the optimum business model for each market.
In some segments, it offers hardware. In some segments, it rents its hardware to the end customer. And in other segments, it offers direct services based on our hardware to the end customer.
And it's easy to manufacture.
We don't have any issues of scaling to volume at all, because there will always be facilities capable of manufacturing this product.
The technology has been developed and tested. Now the next phase of the launch is ready.
Now Phasor is raising capital to develop a product to enter into the market in middle 2014. So Phasor Solution is very pleased to be working with Harwell Capital in this funding round. Harwell has a long track record and a long experience of working with our existing shareholders, and so far have been very enthusiastic for working with us. A third of the funds will be spent on human resources, a third of the fund in bringing in partners to accelerate and to perfectionize the product that we will launch in 2014, and the rest third will be spent on manufacturing.